Welcome. Hopefully you can hear and see us. I'm Duncan Smith. I'm the Chief Operating Officer at the ACB, and joining me is Andy Simmons, our Chief Exec, with Sam and Sue in the background, pulling the levers that make all this happen and work. We've got Sarah Edmonds on the call, as well as Jeff Colley, both ACB members, but respectively of ACAN and Passive House Plus magazine, sorry.
Be careful there.
Yeah, I have to be careful. I know we wandered into a completely different session. First of all, thanks for coming along. Thanks for joining us. I know that everyone's incredibly busy just now. The point of today's conference, we feel, is to engage with our existing membership, engage with new members about some of the work that we're doing, some of the work we have been doing over the last 6 months or so. And just to tell you what that is, the scope that we've been involved with, the type of work, what we're trying to really do, what we're trying to change. It's really encouraging. Membership in the ACB is at an all-time high, and we really feel that's a reaction to some of the challenges that we have within climate change in the built environment. So we want to showcase some of the work that we're doing, but also some of the work that our members are doing, particularly people like Tim Martell. And reach out to, as I say, non-members about the benefits of becoming a member and what we are trying to achieve. So I'm not going to talk too much just now because I'll introduce Sarah and Jeff fully, as well as some slides from Andy. The format of the day, we've got 6 presentations covering a range of different topics. The ability to listen or to view subtitles is on Zoom just now. It should be available, and we'll be recording the sessions to put them on our YouTube channel. So without any further ado, I'd like to welcome Andy, and Andy can give us an idea and through a few slides of what we've been up to over the last few months.
Okay, so what we'll do with the slides is we'll just sort of pop backwards and forwards, using them to illustrate points as we chat through various aspects. But I'll just give you a quick fly through to show you what sort of illustrate the sort of topics we'll be covering. But first of all, I think we'll just talk a little bit about some of the things that the ACB's been or currently focusing on. So one of the sort of main focuses continues to be retrofit. And we've been working with a small technical team, ACB technical team, doing a little bit of research into rising to this challenge, this criticism that deep retrofit is undoable at scale. And we've been exploring it a bit, and it's a good question. And we've tried to sort of stay a bit sort of flexible in our thinking about this. So what we've looked at is, should we extend the current ACB retrofit standard, which is a whole house retrofit standard, into what we used to call a shallow retrofit or a light retrofit with a heat pump. And it's bringing together, it's trying to understand the benefits of the decarbonising grid, lifetime embodied carbon, which of course arises from not only putting a heat pump on a building, but all the insulation and other materials that go into retrofit, and trying to make sense of that in the short term and then the long term. So we'll talk about that in a bit more detail later. It's been very interesting bit of modeling using PHPP, talking, sort of getting feedback from technical teams, sort of lived experience out in the retrofit world. Very interesting process. We've been working with the Scottish Government on exploring its attempts to develop a retrofit standard for Scotland. We've been involved with the British Standard Institute working group developing a retrofit assessment standard. We've just published a report by David Olivier, which is us looking at what's the future of materials in terms of which are the most likely to be decarbonised in the future, and therefore which are the most likely that us or our descendants will be using to build buildings with. So that's available via the ACB website. We've continued to plan and explore how to best redevelop the ACB low energy buildings database. That's an ongoing project, but we're looking to sort of have that reworked, the first phase reworked in September, in the autumn. We continue to support the great work by Tim Martell, developing PH Ribbon, the lifetime carbon accounting tool. It has other features as well, not just that, but you'll hear about that later in the day. The Carbon Light Training Centre has launched the retrofit coordination course, which we'd encourage all of you to have a look at. We are planning how best to not redesign, but sort of improve, update, and perhaps modularize our original Carbon Light Retrofit Foundation course. And we've been developing some training modules for the BEST Centre in Scotland. We're also developing a conference for this year, so back to face-to-face meeting, and that will be in the autumn, working with some our educational partners, the New Model Institute for Technology and Engineering, and that will be based around their Centre for Advanced Timber Technology in Hereford. There you go. So Jeff, perhaps if you want to kick off the conversation, get us going.
Okay, yeah, thanks, Andy. Well, I guess I'd just like to start by talking a little bit about my relationship with the AECB and why I think it's such an interesting organization to be part of and to be connected with, from my perspective as a sustainable building publisher and advocate, from the other side of the Irish Sea. For starters, I really like the fact that we have the opportunity to go against the kind of Brexity grain and start and build bridges rather than walls. Not Boris Johnson style. Sorry for the swear jar there, Sarah. The Tory swear jar that we practice on our podcast, but not vainglorious projects that will never be built. I'm talking metaphorically, to be clear. But there's an awful lot to be learned through a kind of an open, collaborative approach, and I think. One of the things that, when I started the magazine that ultimately became Passive Face Plus 20 years ago, I knew nothing about sustainable building, and I didn't really pretend to know anything. I came into it from this perspective of just asking stupid questions, and thankfully that can endear you to people, and some people will be very forthcoming. But one of the things that you learn, and it's a problem I think in all walks of life, and we certainly have it within our industry, is that there's an awful lot of spoofers out there, and there's an awful lot of people who are well-meaning, but whose ego, perhaps, and in a competitive marketplace, prevents them from showing that kind of vulnerability. Having to pretend that you have all of the answers is a fundamental problem in our industry. We are all learning. The cliche "every day is a school day" is absolutely true, and that's one of the things that's really impressed me about the AECB in my dealings with it, is that there's this intellectual restlessness and this genuine thirst to really probe into the nuance of these issues. That can be difficult, I suppose, at times, because we live in a time when people are looking for certainty and simplicity, and it's probably why the AECB has been a bit of a sort of sleeper organization that's grown organically, in the way that it has. But I think it's one of the reasons why we need it more than ever. So when we look at retrofit standards, for Andy to be talking about this, to actually be asking these questions, that shows a willingness to be open, to acknowledge that we don't necessarily have all of the answers. We don't necessarily know all of the right approaches are straight away, and that we need to, as the evidence changes, we change our positions. So I think that's a really thorny one as well, the idea of engaging with shallow retrofit, because of course there are these legitimate questions about whether we adopt approaches which lock in mediocrity and undermine the business case for really doing the work that needs to be done. So that's, I don't think, at all what the AECB are getting at with this. It's a question of avoiding the opposite extreme, whereby you set such a demanding requirement and you are completely inflexible in meeting it, that you're basically saying to people, look, either it's this or it's nothing. And that doesn't wash either. So this is why this kind of relativistic approach, I think, is needed. That's not to say that, I mean, obviously with a magazine called Passive House Plus, it'll be unsurprising to people to think that, you know, we do have views that not all approaches to notionally sustainable building are equal. There are certain approaches that when you subject them to scrutiny, and Passive House being, I think, a really good example of this, can be shown to work very well in terms of actual energy performance and air quality and so on. So, you know, you'll always be trying to aspire to these kind of standards, but it's a recognition that, especially with regard to existing buildings, there are challenges, and there are competing issues that we need to think about. Andy, I think you want to jump in there.
I'm just thinking about what Duncan and Sarah have been talking about for a while, which is, you know, getting people going. I mean, at the moment, we're calling this revised retrofit standard step 1. I mean, we haven't got a name for it, but you know, step 2 is the existing retrofit standard. But there's a big difference in people are desperate to act. They do want to act. They have to act in a meaningful way, and we also have to accept the fact that, you know, current government programs aren't ready. The industry isn't ready, you know, to turn all of our aspirations, our 30 years of aspirations, into a program which is actually achievable or safe, or delivers, you know. So I think what Sarah and Duncan have been talking about is perhaps you'd like to talk about it, you know, this idea of sort of getting people going and then sort of not driving them, but helping us all get towards the sort of better end of performance. I think you had a sort of pyramidal kind of metaphor going here, didn't you?
It's a pyramid.
Triangle, not pyramid, triangle.
Yeah.
Duncan and I have tried to speak about this using hand signals for ages, and then we tried to
do hand signals.
We can share that kind of beyond this. But I'd just like to say, I think this is probably a good point for me to come in. So for anybody who doesn't know me, I'm involved with ACAN, the Architects Climate Action Network. I'm the steering group coordinator there. So in terms of acting and trying to encourage people to find their agency, that's what we're all about. That's why we exist. And I think the reason, and to build on what Jeff said, the reason that I have been drawn to the AECB is because of that sort of values that we share. It's a purpose-driven organization, and it's there to look in depth at the industry and at what's offered, and to work out how can we do it better and how can we do it together. Now, without sounding cheesy, it's very, very much about that collaboration. And I have seen a shift in the way that a huge swathe of the industry want to work. There's a big push in it's almost like since COP, when everybody realized, hang on, like, we actually need to turn all these words into action. And I'm really seeing that, and I'm very much enthused by the way that the AECB rolls with that and understands that everything isn't perfect, and that we have to iteratively learn and reflect continuously as we go to improve that, without sort of waiting for the perfect situation to be launched. So I think generally as a society, we're very much solutions driven. But we've never been in this situation before. And it doesn't serve our future generations to think that we know it all without showing. I think that was a great word that you used, Jeff, that vulnerability. You know, it doesn't help. I'm like you, I joined ACAN 2.5 years ago and didn't know really anything, but I knew how I felt, and I knew I wasn't happy, and I knew I couldn't continue to work in an industry that was causing so much harm without being an active part of the solution. I think when it comes to retrofit and when it comes to the standards, I think getting people going is really important. And to like come to the wedge, whether you show it this way or this way, the point of it is that what we have is a load of building stock and a load of people with these buildings, whether they are the owners, the occupiers, whatever that is, but everybody is sitting in a building somewhere. And none of those buildings are doing really what they need to be doing in order to well, I was going to say to meet our targets, but it's not even just about targets, it's far bigger than that. What we really have to do is get everybody on a path towards the lowest carbon version of their buildings that they have. That won't happen A to B, one and done. What we need to do is encourage and inspire everybody to get on that path, protect the risk, which is what the sides of this wedge represent. We need to protect that risk, and we do that through things like having a whole building plan, taking that holistic approach, ensuring that we are monitoring or that we are evaluating, and that we're feeding that back in again. I mean, you could argue that it maybe isn't so much of a wedge as it is something that's a little more circular, but it is really, really important to get everybody on that path. And if, to build on what you said, Andy, if you do start with this, like, I mean, you know, it's only this and nothing else, you've lost everybody. So you need to show how to make it. I mean, you have some interesting slides as well about, you know, showing the impact of the path on that, which maybe we can look at later. But yeah, I think it's really
I think this idea of what we used to talk about, it was quite a few years ago now, we used to talk about shallow retrofit as something that's a bit sort of a bit bad, a bit naughty, you know. Shallow retrofit, you spread things too thin, you underperform, fuel poverty is bust again a couple of years later, you know, it doesn't get people far enough, but you lock out further improvement. So the thinking with this new approach is that because of the whole house plan, you have a strategy you can work to, and because the first step, I mean, the modeling that we're doing is I'll probably show a few criteria. We're looking at what criteria should we set as the standard, what is important, what is guidance, and it's got to be doable. So even with a light fabric retrofit and a heat pump, we could still strangle it if we set the criteria too demanding. So there's some things that might just not be able to give at all. Airtightness, is there a hard, you know, figure for airtightness that has to be achieved? So we're constantly questioning ourselves. We are going to have to resolve this within, I think, 2 or 3 weeks. That's what the target we're setting for us.
No pressure.
And having conversations with people like Paul Kenny in Ireland, you know, he's also quite challenging to us, because he's focused on something that's doable as part of a government program. But anyway, so the approach is the step one part of the retrofit standard won't lock out future improvements. Now, it may be that this first, you know, topping up your attic insulation, trying to improve the air tightness down to 5, you know, not insulating the floors. It assumes that there's cavity wall insulation there. If there isn't, it has to be added, and that there are sort of typical plastic double glazed windows. So we assume there's a certain level there. If the house is particularly unimproved, then you would have to sort of add those other measures as well. But still, it's a £15,000 to £20,000 max kind of, you know, investment, whereas a full house retrofit currently, you know, it's higher than that. It's higher than that just for the straight retrofit. So with the whole house plan, you don't lock out future improvements. Now, maybe people taking that first step, spending their 15 grand, and of which hopefully 8 or so will be a grant for the heat pump, they can achieve cost parity on the models, on the house types we're looking at. It may be that the solid wall properties that don't have the benefit of the cavity insulation have to then move to renewing their radiator system. They might have to double up or even triple layer their radiators, which is relatively low impact in that household. But we're trying to keep from sort of jumping, I guess, to the solid wall insulation, just to keep the integrity of that first step. But people may or may not, over the years, further improve that building. And it may be that they do the step one, they reach cost parity or maybe a little bit better with gas, with natural gas, running the heat pump, the cost of that's important. And that house might sit there for 20 years. You know, and then the heat pump needs renewing, and they might just renew the heat pump, and that's fine. And we've looked at the embodied carbon, lifetime carbon of that, and it looks okay. There is the question of, you know, all of these millions of houses done like that will still demand energy from the grid. And at some point, maybe in 10 years, 5, 10, 20 years, the government will say, actually, we need some of the other benefits of deep retrofit. You need to further improve your house. Here's some incentives to do it, because we've put some value on public health. We've put some value on indoor air quality, health and well-being, you know, avoided NHS costs, and they value the non-energy benefits, which allows them to incentivize the deeper retrofit. And it's just this, we don't know what the mix will be. You know, will there be sort of 20 million step one homes rolling forward through the decades, or will there be, you know, sort of 10 million and all the rest of deep retrofit? We don't know. So we have to remain flexible and offer these practical, flexible routes. Duncan, did you want to?
I think that's it, Andy. I think you know, we can come back to Jeff's kind of words. It is a bit of pragmatism and a flexibility that doesn't lock in poor performance or unintended consequences. What I'm keen, we're trying to make this session as informative and interactive as we can. So what would be great, I posted some chat saying, look, if you've got questions, please put them in the Q&A session. We'd like to kind of take them. We aim to finish here, I think, Sue, around about 10:15. So we can talk, we're happy talking amongst the four of us probably all day, but
Too much.
quite keen, yeah, just watch. But if it'd be really good to get some of your feedback and interaction, and we welcome that. But I think what Jeff is saying is, yeah, we don't have all of the answers, but we've got a pretty good idea where we need to take things. And the term that I think we all collectively use is it's about the reduction in demand for energy, because that is the only sustainable way, both from a grid capacity and both from an end user capacity. So we have to, whilst we don't have all of the answers, we have a really good steer in terms of how we need to decarbonise. And I think that's the key term is that we use outside of the ECB from those who might not have the same level of building knowledge that we have in this kind of virtual room just now. It's about demand reduction. It has to be about how heat pumps can work, or how low carbon heating can work in a way that's viable and sustainable, both from a grid capacity as well as an end user capacity.
Shall we have a look at a slide? Because I think that's quite a good moment to have a look at this. Will the decarbonising grid do everything for us? Well, of course it won't, but how much do we have to reduce demand? So if we have a look at
yeah, and while you're pulling that up, I'll just say as well, if I can interject, I had meant to add that not knowing all of the answers is one thing. I'm not trying to suggest that the AECB is just a bunch of curious buffoons. They do know things, and one of the things that I think is also very attractive about the organization is that there has been this long-standing kind of brutal honesty, kind of commitment to transparently kind of discussing and sharing information about what has worked and what hasn't. So we do know things. There's a lot of stuff that we know, and we can all have quite a lot of confidence about the kinds of measures that can be done. But there is nuance to this stuff.
Yeah, and we've shared a lot of that into our training material. So if you look at the Carbon Light Retrofit course, there's a lot of warts and all in there, which of course is one of the very best ways to learn. Where do things not quite work out and how do we do it better? So the reason I've got this slide up is because as part of trying to understand all of this issue of how far do you go with retrofit, we have a short while ago now, but we worked with the National Grid Modelling team and tried to understand what their expectations were about demand reduction. So they have, through their future energy scenarios, created a sort of view of different pathways, different potential pathways in terms of how do we change our heating energy supply away from fossil fuels towards this mixed basket of technologies. So this is just us looking at what they're suggesting in the different scenarios and thinking when we do our own modeling, what might we think is the most likely kind of mix of technologies. So in this particular scenario that we're focusing on at the moment, you can see that there's a bit of so moving away from gas boilers to provide heat for homes towards some district heating, a bit of direct electric, some ground source heat pumps, but not that many because there are problems getting access to ground. A lot of air source heat pumps and some remaining gas boilers. Views about biomass and so on are sort of like disappeared into very small sort of contributions here. So what they're also, they don't understand buildings, and they know that, and they said they were keen to find out, but they do have assumptions about how as they move, as we electrify heat or move it over to district heating, we have to grow the supply, and therefore we need to match supply and demand. So they do have assumptions. They do assume that the demand from homes will increase, and these scenarios here is what they're telling us they are expecting to see as they grow the decarbonised heat supply. They do expect to see, under these different scenarios, which are the different colours, the average heat consumption of homes reduce. So, for example, that green line there, that's the leading the way transformation, which is a more electrified version of the future and more heat pumps. Similarly, the consumer transformation, it includes a lot of heat pumps in that, whereas the steady progression is a more conservative view of what they would expect. So, I mean, you can get lost in these scenarios, but those numbers start to give you an idea, and just to remind people that this sort of typical consumption, gas consumption in the UK is around about this sort of 12,000 kilowatt hours per year, most of which is used for heating the home, which is why we've long concentrated on heating, because it's a bit of an intractable problem. And it needs to be tackled in advance, because these things take a long time to try to sort out. So we focused on heating for quite a long time. So if we go back to this demand reduction here, you can see, so down from 11,000 by 2050, the typical average consumption for heating in the house has got to be somewhere around this zone here. And we're pretty much assuming it's really got to be down at this level for the electrified heating scenarios with lots of heat pumps. So it's about 50%, isn't it? 50% reduction, some sort of trajectory there. So that's where we've got to get to, and that sort of informs our thinking.
Well, Andy, there's a question that has come in, possibly not in the right order, but this one might be something to lead on from that. So I'm going to read it out. Question is, AECB has carried out the only study I know of that aims to optimize all costs, direct and socialized, including grid strengthening, renewables, ill health burden, etc. This is the basis of the AB retrofit standard. Is it worth revisiting this analysis, considering 1, reducing costs of wind, etc., and 2, the dire global impacts of climate change happening now? And he goes on to say, my emphasis on that point is that climate change is now almost out of control. A heat pump in an inefficient home is better than none. I think this is an interesting conversation to have. I mean, we interviewed Peter Rickaby on the podcast not so long ago, who was of the opinion that until we really get this demand reduction issue well in hand, that it's probably worth considering one more generation of gas boilers before we do that. And I suppose it really, the goalposts really have shifted, I suppose, given the energy crisis and the price and the cost of living. So it's a really sticky question. Duncan.
Well, yeah, so I'll let Andy come in about the initial part of the question, but what I think and I'd welcome more questions. I think we've had a few come in, which are good, but let's get some more, because you've had half an hour of us and we can hopefully then try and answer some of your questions. But I think one of the things we've been focused on, because let's be honest, we're all in a fabric first sort of camp. That's where we've come from over the last decade and beyond. And I think our particular focus is on being how we design and deliver solutions that are based around professionals designing work that's that fundamentally addresses the demand side of energy and doesn't lock in those unintended consequences, as we say. However, what I think we have to be mindful about is I think heat pumps absolutely have their place, but I think, and this is through a lot of work we do in the podcast, Sarah and Jeff, that we shouldn't assume that everyone who fits a gas boiler just now should be able and could be able to fit a heat pump. And I think we have to be slightly cautious about heat pumps as a panacea. They have to be designed and they have to be commissioned in in a much more sophisticated way. Now, if you speak to people like Joe Alsop, they'll tell you that a significant proportion of gas boilers in the UK condensing gas boilers aren't actually designed to be condensing gas boilers. So I think I would just urge a little bit of caution, and again, in our approach is about the design of heat pumps in a more sophisticated way than perhaps the industry is capable of doing just now. Is that fair to say, Andy, Sarah?
I think so. I think that I like the way we're feeding as questions come in. I think it's good, yes, to read them out rather than leave it to the end, so we make sure we are answering questions. I think the climate change is pretty much out of control, isn't it? To be honest about it, and there is no silver bullet, and there are different approaches to retrofitting depending on the opportunities in regions, particular buildings, and so on. But we do need to be thinking about doing it at scale. So the question is putting a heat pump on any building better than nothing? This is we've looked. I'm going to show you a carbon related slide, because this is in a way kind of where we're trying to understand the most. Where's me? Here we go.
There you go. Yeah.
Okay. So there are 4 slides in here. Let me just remove that. Right. So let's have a look at we've talked about the decarbonisation of the grid on the right. Now, I'll just make a quick point about that. These are idealized scenarios of what people expect to happen in the future. We must remember that at the moment, the actual measured carbon coefficient of the grid is higher than the idealized projected. And we do need to keep an eye on that, because that's basically a performance gap, and that's what the atmosphere actually sees. So if you look at these two graphs, bottom left, bottom right, what that is showing, we're using pH ribbon to do lifetime carbon analysis of the heating system of a house, and what happens when you put some materials and some equipment on it to put a heat pump, make some, put some insulation on, and so on. So the carbon burp relates to the embodied upfront emissions from the manufacture and so on of what you use to do the work. The grey bar down here, this shows you the emissions, the carbon dioxide emissions from the heating system each year. So what we've shown in this little graph here is the first, we've got 5 years of this typical semi-detached house, cavity wall insulation, plastic UPVC windows, a bit of attic insulation, and so on. Air tightness, I think we set as 9, N59. And that's 5 years of burning gas for space heating, and that's the emissions that relate to that. That's just under 3 tons there. Now, if in year 5 you do a step 1, which is this light retrofit, so you top up the attic insulation a little bit, you do some air tightness measures to bring the air tightness down to 5, and you put a heat pump on it, a 5 kilowatt heat pump. I think that's what this scenario shows. So you can see that immediately, yes, there's a carbon burp, as we call it, in the first year, but you slash your heating, greenhouse gas emissions from heating. So it looks like a very sensible thing to do. And then, of course, the grid continues to decarbonize following these curves. And so your remaining heating energy is decarbonising. Now, if for whatever reasons, whether it's peak heat demand or other co-benefits of a deeper retrofit, if you do that deeper retrofit, say when the heat pump needs renewing 17, 20 years later, because you're using a lot more materials, you've got a bigger carbon burp, and it looks terrible, doesn't it? Yes, you reduce your space heating emissions a little bit more, and then you've got to renew the heat pump, and there's another carbon burp there, because this is an ongoing process. You don't just do the building, it needs to be maintained and equipment needs to be replaced. But if you look at it over the 60-year period, this is the cumulative carbon CO2 emissions that comes from that household in terms of its space heating. And you can see the grey area here is just continuing to burn gas. That's what it looks like. The CO2 emissions just rack up and up and up. This is tons of CO2 up on the left-hand side here. So both of these retrofits completely change the trajectory of the carbon emissions from space heating. Phase 1, happening in year 5, flattens that curve, doesn't completely flatten it. So there is still some offsetting technically needed for that, but that red dotted line shows you where that light retrofit with a heat pump, including the occasional replacement of that heat pump, sort of heads. It's a nice flat line, which is what we want. We want flat for cumulative carbon. If you do a phase 2, yes, you expend a bit more carbon. You've used up a bit more of your carbon budget, but it's not so bad seen in the context of cumulative carbon. So I think you've got both options available to you in terms of your impact on the atmosphere.
I'd just like to add, if I can, that I think it's a really interesting question, but I don't think we should tie ourselves up in knots about whether it's, I understand Peter Rickaby's perspective and I have an awful lot of respect for him, but on this point, I think if we're getting into a position where we have enough heat pumps installed that we're starting to worry about this, then I think that's a good place to be. And I'd rather be, frankly, proposing an Instagram or a TikTok tax to stop people. If we're going to prioritize electricity use, decarbonized electricity use, it should be for our needs, for our real needs, and I think there's a priority of needs that should be kind of a consideration in that regard. There was a question in the Q&A.
Before we move on to that,
Yeah,
I just want to add to that as well. I think one of the most impactful things that I learned this year was from, Duncan, you mentioned, from Joe Alsop and Leah Robson when they were talking about optimizing our existing heating systems and the actual, both the public service that would be delivered if everybody knew that they needed to turn their flow temperature from 70 degrees to 55 and to understand how to live with that. and to set your radiators that it's low and slow. And immediately you have educated, you know, the country on low flow temperature heating systems. On, like, right now, there's this fear, I think, we've talked about this many times. There's almost a fear of, don't touch my thermostat, don't touch my boiler. People can't afford the call out if something goes wrong with their heating system. And it's always been that way. And there's always this sort of like tension around understanding how that works. It isn't that difficult. And this is what Leah and Joe have been working really hard around doing, about this education bit around this. We would save vast amounts of carbon. We would put people in far more comfortable situations just with that bit. Just, can we understand what we have in the first instance? Because that's another really key part of getting everybody involved, excuse me, is understanding, how does your heating system work? How does your home work? Why is air tightness important? It doesn't mean sealing up your house and so that you can't breathe and can't have fresh air. That's not what it means. So if we could kind of do this explainer bit, which, you know, let's be honest, our government's never going to do that, but they should, and it would be a good news story for any government. So there's a bit around that. That then makes people understand how a heat pump system, it demystifies a little bit how that works and why the temperature is lower. It doesn't mean you're going to be colder. It means you're going to have less, you know, 0 to 90, hot, cold, and everything that goes with that. You know, it's a really important bit before we kind of worry about, as you say, Jeff, are we even installing that many heat pumps yet? Have we got people to install them? Have we even got the heat pumps? Like, and that's why it's really important to continue to do this sort of conversation, collaboration, communication bit as widely as you can, because whilst these standards are being developed, which are absolutely crucial, and whilst we are pushing at the top to say, listen, you need to listen to the industry, we're trying, we also need to bring everybody along with us and empower people to understand how the systems work.
You're absolutely right. So it's not, you know, not just trying to sell people stuff all of the time. That's obviously a fundamental problem with where we are, and trying to properly educate people on how to use their buildings properly, how to live their lives is really important. I would add a note of caution that we should be very careful on the messaging on this. What we don't want, and we've seen it in the UK in the context of food prices, so the cost of living crisis. You know, we don't want government ministers telling poor people, you know, how to survive on 30p a day or whatever, you know, and that it's their fault because they don't know how to cook or anything like that. And we had this in Ireland a number of years ago. There was a government-funded campaign called The Power of One, which was it was a big PR campaign about encouraging people to reduce the temperature in the thermostat and how the power that they as an individual had to reduce energy consumption. And notwithstanding the concerns about this being a well-established ploy of the fossil fuel industry to foist the responsibility onto individuals, there is a point here that that campaign was spectacularly badly received, because I think it was described pejoratively as the power of four, Dublin 4, as the kind of the affluent part of Dublin, and the actors who did the ads for the campaign were very well-heeled sounding, you know. So you have to make sure that you there's a lot of sensitivity required in how that message is delivered, you know.
I just want to play host for a wee second. There's some really good questions coming in, and I want to make sure we answer them. I think we've probably answered Martin's coming in the Q&A and asked about drop in flow temps. I think, you know, the way we become heat pump ready is how we can use our boilers more efficiently. Just now, that's certainly one of the. So hopefully that's answered your question, Martin. On that, there's a great question earlier on about energy sprong. I'll maybe see if we can, Andy and Jay can pick, because I think there's a, not specifically about energy sprong, but whether we look at comfort as a service as a question. So not specifically a product type, but a service type is an interesting question. A couple coming through on air permeability or tightness, and I think that's something we want to tackle, because the question is answered, how do we do that with people in situ? I've got a specific project I'm working on just now, which I'm hoping to do a lot of external work with a product manufacturer. It's really exciting. But there's one good one that I saw just now is about ground source heat pumps, and I'd like to take this if that's okay, but everyone else can chip in, because one of the things. So I've been involved in delivering large scale district systems, renewable systems, and a previous life, a gas system. And I think we're talking about heat pumps, and we tend to talk about heat pumps in an individual sense, and we talk about district in a grand sense. And And if you look at Denmark, I don't think they consider anything less than 2,500 units to go district. What I think in terms of ground source we have, and feel free to challenge and come in, I think there's a solution in between those two. You know, there's big urban areas that will, London, Manchester, Birmingham, that are perfectly placed to distribute low carbon heat through optimization of schools and offices and homes. But in some of the more suburban areas, especially where we have low-rise flats, in Scotland we call them sort of cottage-type flats, I think that, and we have obviously front and back door properties, bungalows and so on. I think there's something that hasn't been developed as a concept, which is about block heating, which is perhaps ground source serving 4 units or 6 units, and how we can commonly harness some of those technologies in a way that perhaps, because of the size of the flat, because of the location, we couldn't do individually. I think what we don't want to go down is having an array of 6 air source heat pumps behind a block of flats. So what do you think of that? Is there something that we haven't done that's emerging, do you think, Sarah, Jeff, Andy, in terms of how we address heat at a block level?
I think, sorry.
I'll let Andy go on in the detail of this. I think just one observation, and it's exactly what was building in my mind when we're talking about, you know, the heat pump revolution, and we really don't want to see, like, I live in a 3-story building here. There are 4 flats in this building. There are 4 gas boilers in this building. That's bananas. It's absolutely bananas. And I think, yes, whole block heating systems, like Sweden does that. Like, we've got, and it's not new technology. This sort of stuff drives me mad. You know, this sort of individualistic tendencies towards the way we do everything is just not going to work. It's not going to work. We have to do it in another way, which is why the education bit and the sort of the shift of values and the shift of appreciation of what all of that can mean for us is really, really important. It's the story of how we revolutionize, how we heat our homes, and how we engage as a neighborhood and as a community, not just like, yeah, I did my bit, I'm fine. Like, that's not going to get us to where we need to get to. But Andy probably had something a little bit more technical and less ranty.
Well, I wasn't actually. I was going to be a bit gloomy. You know,
no, the sun's shining today.
I will be gloomy. I will. Denmark, you know, countries which have had, you know, there have been things, even Ireland is at a more advanced stage with its retrofit program because they spent many years longer preparing the ground. Denmark has been building and developing infrastructure and heating infrastructure, district heating, and, you know, I know it's climate induced as well, but sort of better standards of building for many, many years and decades. And that's a long time for us to sit here and be talking. I don't know, none of us really are saying this, but, you know, if we're giving the impression that we think because we're looking at grid issues and we're looking at, you know, long-term future scenario projections, so we think that the ACB standard is part of a sort of a viable, you know, program which will decarbonize our building stock. I have no idea whether we will rise to it at all, because at the moment we're clearly not. There's a lot of talk, a bit of modeling, a lot of you know, misguided thinking, some things that sound sensible, but we've left it way, 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 way too late. And if you're going to be, you know, if I'm being honest, I would imagine something more Blade Runner, you know, kind of happening. Somebody's phone there, is that you see? But however, we have to keep trying to do the right thing and to be useful in what we're doing. So contributing these, you know, whether it's a standard or or thinking or whatever we're contributing, it's all helping nudge things in a more, you know, in a direction where we get sort of better outcomes. But there's no point in underestimating the fact we've got very few years to be doing this. And so in our, you know, you've probably seen the ACB's looking at adoption curves, you know, how quickly will retrofit take off at scale and when will it tail off? And many, you know, was it 3 years ago or something, we looked at the Green Party's proposals, and it was like imagining doing all the retrofit, bang, really quickly, and then finish it. It's utterly ridiculous, impossible. And so realistically, this is going to be a much longer term project. The question is, what happens in the interim? You know, will we continue to burn gas and then sort of argue our way in the world? I'm sorry, we can't decarbonize our heating systems. Agriculture will have to pick up the slack, or we'll sort of, you know, get a few million acres in Africa and offset it in some way. You know, it's going to be a messy and unsatisfactory process, but it doesn't mean we're not doing useful work here. What happens in the meantime? And I think, Sarah, you know, just talking about people using the gas boilers more efficiently. These are really important programs. Unfortunately, they're not quite as interesting to get involved in. They need to happen, and it's a clear, easy win for government to get on and do something like that. It's almost cost free, and I think why is it not happening? We know why it's not happening. Where's the incentive to reduce the gas sales, energy sales? Duncan.
Just think David has got a great point here, and grid capacity, and I have some knowledge of grid capacity, having worked for a power company at one stage in my life. I would like to come on to the energy strong question. So if one of you, Jeff or Sarah or Andy, want to pick up on that, would be great. But I think David makes a really good point here, and again, it just articulates the argument that we have been promoting, is that, and this is something that's not entirely well known. So we have energy production and we have energy distribution, and certainly in Scotland, the distribution companies are actually separate companies from the power production companies. Now, if we want to decarbonise not just our homes, primarily using some form of electricity to heat them through heat pumps or so on, and if we want to decarbonise our cars, what is not fully known is the investment required to increase that capacity, and that's something we just need to be aware of, because that comes at a cost. That particular cost is a social cost, and it's agreed by Ofgem, and it is then reflected in our bills. So the network infrastructure companies. It's a really good presentation was that last year by Scottish Power, who said that, and I got this wrong in the podcast, a 10% switch in Scotland from, this is Scotland, so it just gives you an idea, a 10% switch from gas, which would be about 200,000 gas boilers coming offline and going on to electricity, would require 100% network upgrade. 100%. Now, there's a diminishing return after that, but I think the point there is, how much more capacity we would need to build? And it's significant. It's possibly 200 or 300%. I don't really know. The network planners would know that. But that is, again, a great example of why we need to reduce the demand, because the lower you have in demand, that we will pay external costs through these types of upgrades as consumers, or we will pay through increased bills. So just a really good question.
I think we should remember that the demand reduction through fabric measures and demand reduction through the efficiencies of heat pumps. I know it's technically incorrect to say a 300% efficient heat pump, but that does reduce the demand by a third. So
it does, yes, it does. But if you are taking away gas and increasing electricity, of course. So yeah, I think the point is probably multifaceted. It's about designing heat pumps properly. It's about reducing the load that heat pump will be operating at. There's lots of things in there, but again, it just articulates in a way that's nice to hear from others that we have to.
Yeah, I don't think the ACB is moving away from recognising that we need to, on average, reduce the heat demand of the building stock by about 50%, and that requires deep fabric measures, good air tightness. But the realities of the current government, the realities of the culture of our industry, the way business models, it's not working in our favour.
And that's what's really important about the bit where we all started about, which is why the AECB, why BEST, why ACAN, why all these organisations, and why are we trying to do everything we can to collaborate and share? Because this is part of culture change. This is part of that. It's sort of, the bit that Jeff mentioned about vulnerability. It's like the industry are saying, we need to learn from our mistakes, and we need to share where we've done right and where it's not worked out well, because there's massive learning in that. And that hasn't been the way of the industry until now, where it's been much, much more about, ta-da, look what we made, and it's perfect and it's lovely, and there was no mistakes on the way, and it came in on time, on budget, and and that doesn't help anybody. That just continues to underline this sort of like pushing against each other instead of pulling together. That's really important, because we are going to need all of these routes, every bit of it. We're going to need loads of people to just throw heat pumps in, whether they work or whether they don't work. We're going to need loads of people to do internal insulation, external insulation, try and push as much on natural materials as possible, because I think there was another question about air permeability and the need to understand how moisture works in buildings. And there's an excellent building physicist, Gloria Lowe, who will talk. I think we should probably listen to her and her knowledge about how moisture moves and her concerns over retrofitting cavity wall insulation. Like, there's lots of really, really good knowledge out there, but what's important is that we get that information out there and that we debate it out there collectively. Because what can happen, and the bit that I'm sort of worried about, is if only a small group of people take this conversation to a point and then end up somewhere which is, so maybe we need to just do light retrofit. It's a bit like what you talked about, Jeff, where there was a press piece in Ireland saying, oh, deep retrofit is dead, long live shallow retrofit, or something. It isn't that. It isn't like this is the answer. There isn't one. It's lots, and it needs to be, as you mentioned, Andy, it's got to be an iterative process of learning and reflection that's shared, you know, so that everybody.
Well, that is the ACB way. You know, members do build, they do share, and we do learn and move forward. But how does that, you know, what about government policy? You know, the government policy for grant funding heat pumps. And similarly in Ireland, you know, looking at Ireland and asking those same questions. So you're rolling out a retrofit program, heat pump based retrofit program. If policy, how agile is policy? And how integrated it, assuming it you know, departments talk to each other and an integrated policy comes out. Do you run it for a year and you throw a load of monitoring at it, and then you immediately say, we got it wrong, we'll change it? You know, that's not the culture of policy making, is it? It's embarrassing if.
Well, no, but in Ireland, it's, you know, what we've done, and I'm sure you've done this a lot in the UK in the past. Our deep retrofit policy was based on pilots. So we had pilot projects. The evidence from them was studied.
The 20 house project.
There was more than that. There was a deep retrofit pilot scheme where there was 400 homes that were deep retrofitted, and the evidence from that was in varying degrees of detail. Was
forgive me, Jeff, for that. Is that published, that 400 home study?
No, some parts of it are. Some of it will be coming into the NZEB 101 study that Shane Coakley at UCD is monitoring, and there are other universities involved. NUI Galway are doing monitoring as well. Some of it would just be internally held by the Sustainable Energy Authority of Ireland, who commissioned it. But I just think I'd re-emphasize this point that, look, you know, I'd love to be an environmental despot who can just, at the flick of a switch, you know.
So it's not the first time you've shown those.
I know, yeah, I've got that tendency within me, you know, and the environmental thing, I just take it or leave it. It's just it's the control over everyone, you know. So I think the point is that we're not, whatever we do, and even with this government program in Ireland, like, they've got a huge challenge to get anywhere near delivering the targets that they've got. You're not going to get into a situation where the kinds of measures we're talking about, yes, there are issues with regard to the electricity grid, for instance, you know, but I don't think we're going to get into a situation anytime soon where the decisions that people are taking on projects now are going to have are going to be a drop in the ocean in terms of that's a bit of an understatement perhaps, but in terms of the impact on the electricity grid. And again, Peter Rickson talked a long time ago about you know, pre-COVID about actually, it's architects love building stuff and talk about building the city of the future, but actually probably what the future is going to look like is people not moving about very much.
That's the point of flexibility, isn't it? The issues of the grid, we did start obsessing, you know, about peak load issues, but it's not a problem now. So let's get on with, you know, design our standards on what we do now for the conditions now, anticipating what might happen in 10, 20 years time.
Yeah. And, you know, there's all sorts of community microgrid stuff that's starting to develop pace as well, which offers some, you know, some solutions in this regard. But we should crack on with a couple of these other questions because we're rapidly running out of
I've just
time.
Got our stage manager whispering in my ear we have to have a costume change for our 22 session. So yeah, we've got a session coming up. If anyone's on staying on, we'll get a really interesting session with Tim Martell on pH ribbon. And Jurgen from the Passivhaus Institute on PHPP 10, so that's really interesting. Came up at 10:30. So we've got, will we say 5 minutes left? Yeah, let's take some of these questions. I think
really quick fire glib answers, everyone. Okay. Okay.
What do you think of Energy Sprong? Go.
Yeah. Well, I think, can I reframe that question and not talk about a specific business model? What do we think about comfort as a service? That's, if you don't mind, I think that's an interesting topic. And also, let's combine air permeability with ventilation. Somebody had asked about NVHR ventilation. Let's talk about ventilation, how critical it is. I think we all agree, and NVHR, and let's look about comfort as a service. Yeah.
Yeah, comfort as a service. I'll just chip in. You can throw me out. Very interesting, challenging to put in place as a business case, but the idea of, especially when you've got restrictions around property ownership and liens on property in terms of bank finance and so on. But if you can attach a debt in that way, you know, like get people to pay for comfort rather than kilowatt hours, then I think that it's an interesting business model. And then it inverts the normal utility model, because it makes more business sense for them to sell you less kilowatt hours to deliver the comfort, you know. So that is interesting.
Yeah,
you want me to talk about? Oh, sorry.
No, well, Scott Foster says, so the ECB is part of the United Nations Centre of Excellence for High Performance Building, and Scott Foster, who we all know, has a really interesting presentation where he talks. He sort of holds up his phone and he said, "Look, you know, nobody would think about spending, you know, the price per minute for a phone call, the price per text anymore." And he says that heating, domestic heating, is one industry that every other industry has changed, whether it be broadband or streaming services, where we have to look at how you buy comfort, and the optimization of how that is done is with the seller of that comfort rather than the individual. I mean, everything in terms of energy efficiency in the UK is primarily with the individual, isn't it? You know, we're told to turn down things and so on, but there's an efficiency you can create at the seller of that energy that I think is quite appealing. So sorry, yeah, Andy, on you go.
I was just going to answer the ventilation question, because I've just opened up the ACB technical group's response to me on ventilation, and I think I'll just give a little sort of potted summary of where the consensus is developing. So we're thinking that we should try to remove the link between air tightness, air permeability, and ventilation, because we want to see every home have a well-designed ventilation system in its own right, independent of how leaky the building is. In terms of MVHR, clients tend to choose this with comfort or indoor air quality in mind, and we think that can work at most levels of air permeability, not just the sort of super tight passive house levels. And then in terms of decentralized room by room MVHR, we're not seeing huge advantages in that, and have some sort of concerns about the cost of it. It does add up, room by room MVHR. The noise issues might relate to that, and also, does it give good indoor quality? I think the jury's out on that. Where we think the mainstream will be going is rather than whole house MEV, mechanical extrantor ventilation, which is good and works well, with some caveats about it being bypassed by the stack effect sometimes, is continuous running wet room extract fans, humidity controlled. That's kind of seems the obvious ventilation solution that will work on a wide, on a mass scale.
Yeah, I just chip in to say that green building, there's this old school view about natural ventilation as being preferable to mechanical. It sounds much nicer, doesn't it, natural than mechanical? But we need to move away from magical thinking. I don't want to be dismissive. Any mechanically ventilated building should have the option to naturally ventilate too. You always have the option to open windows and regulate ventilation in that way. But you need a ventilation system that is going to be able to deliver a predictable amount of air changes in all conditions. And even with highfalutin passive stack ventilation systems, there are going to be situations where it's almost impossible to deliver the required ventilation rate. And when you look at the evidence, and not just the theory, and not just the desktop studies, actual empirical monitoring studies, the best example for me was a brilliant, I can share it later in the notes, a systematic review of the health and ventilation rate relationship in buildings. And when it came to natural ventilation, the conclusion, this is a study of 180 different studies they reviewed. When it came to natural ventilation, the conclusion was devastating. They basically said, with natural ventilation, there's no way of knowing whether the results in the individual studies were right or not. Whether you get a weekly average or spot measurement, there's too many variables affecting it. It's random. It's too, you cannot rely on it as a fail-safe.
Great, thank you. I think we've run ourselves out of time.
We have.
Yeah, well, listen, that was great. I thought that was a really good conversation, and I've hopefully tried to answer people in the chat. Sarah?
I just want to put a call to action. If anybody isn't a member of the AECB, please consider joining. If you are not familiar with ACAN, please come and check us out. just find your group and find a place to continue the conversation, because that's where this change will, and culture change will start.
Yeah. Thanks, Sarah. Brilliant.
That's it. And hopefully Jeff's going to join us at 10:30. We'll be hearing from Tim on pH ribbon. I think really exciting in terms of how we assess embodied carbon and the work that Tim's been doing, and Jeff in the magazine. So hopefully you can see us then. Okay.
Thanks,
Thank you.
Everybody. Thanks for your time.
Thank you.
Bye. Bye for now.